In this lecture, we're going to go over the SQL database introduction. So what is a database? Well, a database is an organized collection of structured information of data, which is stored in a computer system. The data can be easily accessed. The data can be modified. The data can be controlled and organized. And many databases use a structured query language, which is also known as SQL, to modify and to write data to a database table. But before we jump into a database, we might get the question of, well, what is data? So let's continue on what is a database. Well, data can be related to just about any object. For example, if we think of a user on an application, we may think of the name, the age of a user, an email, or a password for a user. All four of these characteristics are all data of a user that might be trying to get into an application. So each user is going to have a name, an age, an email, and a password associated to them. So really, a database is just a collection of data. Since data on its own is just data, a database allows management of all of this data. So databases are organized in how data can be retrieved, stored, and modified. Now, when we're talking about databases, there's kind of a parent of a database. And there are many different types of this, and this is called a database management system, also known as a DBMS. It's the application or the software that is now in charge of the database. Now, some really popular SQL databases are SQLite, and SQLite is going to be the very first DBMS that we use within our application. MySQL is also a very popular choice for database management systems. And PostgreSQL is also an amazing choice for a DBMS system. Now, I keep saying that these are used for SQL database management systems. So let's dive in and learn a little bit more about what is SQL. Well, it's either pronounced as SQL or SQL. You'll see that both are used very often within the production world. SQL is the standard language for dealing with relational databases. Now, a relational database means there's going to be a table with columns and everything kind of makes sense. Like think of an Excel sheet or some kind of sheet where there's going to be columns and rows with data inside, kind of like a table. So SQL can be used to do different things within a database record. And a database record is each row of data within a database. SQL can create data within a database. It can read data within a database. It can update data within a database. And it can delete data within a database. Now, this looks awfully familiar to our HTTP requests. These are known as the CRUD operations: create, read, update, and delete. And SQL will be able to handle all of this for us for our FastAPI application and the database. So now that we kind of did an introduction to SQL and databases, I'll see you in the next video. All right, hey everybody, and welcome to another section of our FastAPI course where we're going to be going over our project 3, which is our to-dos project. And now our to-dos project is going to be a way for us to be able to create to-dos where we can write a list of items that we want to be able to complete. We then have a complete feature where we can check or check off. And we're going to have the ability to be able to prioritize these to-dos. So the very first thing we want to do to get this project started is let's go ahead and right-click on FastAPI. I'm going to say a new Python package, and I'm going to name this package To-Do App. All right, and then Python is going to create this To-Do Python package, and I'm going to delete books and books 2 because we don't really need these anymore because we're moving on to projects 3 and books projects are in the past. So we're moving forward with the course and we no longer need books or books too. Alright, so now that we have our to-do package created, let's go ahead and just right-click on To-Do App and say New Python File. And this Python file is going to be called database.py. And now our database.py file is going to be used for us to be able to create our URL string, which will connect our FastAPI application to our new database. And we're going to be using SQLite. And we need to create some other information for us to be able to open up the database connection, be able to close the database connection, be able to create some database tables. And some of this happens within our database.py file that we now added within our to-do app. Now, one thing to notice is that in our terminal, we still have our FastAPI environment running, which is correct, but our latest file is our FastAPI parent. If we look at our project structure, we can see that FastAPI is at the top, but inside FastAPI, we have our FastAPI environment and our to-do app. Well, all of our logic for this project is going to be in our to-do app, so we don't want to be at our parent root of FastAPI. We want to cd one directory lower into our to-do app. To do this, we can do cd to-do app. We can now see that our terminal has changed the direction from our FastAPI to our to-do app, which is correct. So now inside our database.py file, we need to create some logic. But before we go ahead and create our database.py file, one thing that we need to do is go ahead and install something called SQLAlchemy. Now, SQLAlchemy is an ORM, which is Object Relational Mapping, which is what our FastAPI application is going to use to be able to create a database and be able to create a connection to a database and being able to use all of the database records within our application. So before we get started creating our database.py file, let's go ahead and just say pip install SQLAlchemy. Alright, and now once you click enter, it's going to download SQLAlchemy onto your machine, and that's exactly what we needed. We needed it installed into our FastAPI environment. Alright, now let's go ahead and start writing some of our SQLAlchemy code within our database.py file. Now the very first thing we need to do is create a new variable, SQLAlchemy underscore database underscore URL, which is going to be equal to a new string, which we're going to call SQLite ://, so 3 slashes, / todos.db. Now, this URL is going to be used to be able to create a location of this database on our FastAPI application. Now, that might sound kind of crazy at first, but we're going to dive in and go over everything step by step. But really what we're saying right here is that our database is going to be inside this directory of our to-do app. And you'll see it when we run the application here in a little bit. The next thing we need is to be able to create an engine for our application. And now a database engine is something that we can use to be able to open up a connection and be able to use our database. So before we get started, let's go ahead and just import create engine from SQLAlchemy. So we can go ahead and say from SQLAlchemy, import create underscore engine. Now, once we imported create engine, we can now create a new variable engine, which is equal to create engine. And now inside our engine, we need to add the URL path for our database, which is going to be the SQLAlchemy database URL that we provided. And then we want to say comma connect arguments. Now these connect arguments are arguments that we can pass into our create engine, which will allow us to be able to define some kind of connection to a database. Well, we want to say check same thread of type false. And now by default, SQLite will only allow one thread to communicate with it, assuming that each thread will handle an independent request. This is to prevent any kind of accident sharing of the same connection for different kind of requests. But in FastAPI, it's very normal to have more than one thread that could interact with the database at the same time. So we just need to make sure SQLite knows that, hey, we don't want to be checking the same thread all the time because there could be multiple threads happening to our SQLite database. Now we need to create a session local, and each instance of the session local will have a database session. The class itself is not a database session yet. We will add that later on. But right now we just need to be able to create an instance of session local that will be able to become an actual database in the future. So now let's scroll back up to the top and let's import session maker from SQLAlchemy.orm. And we can do that by saying from SQLAlchemy.orm, let's import session maker. Now we can scroll back down and say session local equals session maker. And inside here, we want to say auto commit equals false. Auto flush equals false. And bind equals engine. So what we're saying is we want the session local, which we're going to be using in our application. You'll see when we use session local, we want to bind to the engine that we just created. And we want to make sure that our auto commits and auto flushes are false, or the database transactions are going to try and do something automatically. And we want to be fully in control of everything our database will do in the future. Now, the last thing we need to do is make sure that we can create a database object that we can then interact with later on. So let's go back to the top and say from SQLAlchemy.ext.declarative, import declarative underscore base. And then we're just going to say base equals declarative underscore base and then parentheses. So what we're saying here is later on, we want to be able to call our database.py file, be able to create a base, which is an object of the database, which is going to be able to then control our database. What this really just means is we're going to be creating database tables. And then here in our database py, we're going to be able to create an object of our database, which will then be able to interact with the tables that we create in the future. Now, this is all awesome stuff, and it might seem a little foggy on what's going on right now, but we will continue to dive into it, and it will start making sense later on as we continue to be able to create database connections with our FastAPI application. But with that, this wraps up creating our database.py file, and I will see you in the next video. Alright, hey everybody, in the last video we went ahead and created our database.py file. Now in this video we're going to create our models.py file. So let's go ahead and just click on our to-do app, say right click new Python file, and we're going to call this models. Now models is a way for SQLAlchemy to be able to understand what kind of database tables we are going to be creating within our database in the future. Now, a database model is going to be the actual record that is inside a database table. So, for example, we're going to have a table that is going to be called to-dos, and inside to-dos, each record is going to have an ID, a title, a description, a priority, and a complete column, which will make sure a record in a database is an actual record that we can then use some kind of manipulation with, whether that's in our FastAPI application, or if we just want to be able to view it in the database. Well, the very first thing we need to import is inside our database, we created a base from our declarative base, and we want to import that into our models. So let's start by just saying from database import base. And that just means that we are going to be creating this model for our database.py file. So the very first thing we can code inside our models.py file is our to-dos, which is going to be our to-dos table. So we can say class to-dos, which now inherits base from our database.py file. We can then inside class say underscore underscore table name underscore underscore equals to-dos. Now, this is just a way for SQLAlchemy to know what to name this table inside our database later on. So now that we have this class to-dos, which is going to mimic the table of to-dos, we can now start writing up the columns that take place inside our table, which is going to be ID, title, description, priority, and complete. Now, let's start with doing our ID. So when we think of an ID, the ID is going to be our primary key, which is the unique ID that distinguishes each record within the database. We also want this to be an integer, and it's going to be a new column for our database. So before we start, let's go up to the top and say from SQLAlchemy, import column and integer. Now let's scroll back down to our to-dos and say ID equals column. And then in parentheses, we're going to say integer. So we're saying this ID is going to be a new column within our table, and it's going to be an integer. We then want to say primary key equals true, because our ID is going to be the primary key, which is the unique ID or the unique identifier for each record. And then let's also just say index equals true. And index is just a way for us to be able to increase performance by telling our database table that this is indexable, which means it's going to be unique. We're going to be able to find it directly, and it's just going to increase performance just slightly. All right, and now that we created our ID, we want to be able to create a string. So let's go back up to the top and look at our other imports. We've imported column and integer. Let's go ahead and just import string and Boolean. String is going to be for all of the word columns that we want to add within our table. And Boolean is going to be for our last one, dictating whether this is complete or not. All right, now let's come back down and say title equals column of string. Description equals column of string. Priority equals column of integer. And complete equals column of Boolean. And here we can say a default value. So everything else is going to default as none or null. We're going to say default as false. So now our to-dos table is going to have an ID, a title, a description, a priority, and a complete option within our application. So just a quick overview of everything we just did. We imported our database, and then we imported SQLAlchemy, where we're saying, hey, we want to be able to create certain records within our table. And then we're going to say, hey, we want to create a new table within our database, which is going to be called to-dos, that has a ID column, a title column, a description column, a priority column, and a complete column. Each column is either going to be an integer, a string, or a Boolean, and we're only going to say our ID of each to-do is going to be the primary key, and we're going to say index is true. All right, so with that, this wraps up everything we want for our models.py, which again is going to create our table of to-dos with each column, but we still don't have any records. So I'll see you in the next video where we dive in and continue adding to our database setup for our FastAPI to-do app application. All right, so we've currently created our database.py file and our models.py file. However, we still don't have a database or a database table created. Now, being able to create a database and a table is super easy with SQLAlchemy. We've already created the database.py file, which has the location of where we want to store our todos.db. And we already have a model, which is going to be our table that we want to be stored in our database. So let's just go back up to our to-do app and let's right click and say new Python file, and we're going to name this main. Now our main file is where all the magic for this project is going to happen. It's going to be our root folder where we create our FastAPI application. Now being able to create a table using FastAPI and SQLAlchemy is extremely easy. Let's start by creating a normal FastAPI application. So we can say from FastAPI, import FastAPI. And then under this, we can say app equals FastAPI parentheses. So we've done this before. We now have our app, which is connected to a FastAPI application. We then want to say import models and we want to import our engine from database, so we can say from database import engine. And now let's go ahead and just say models dot base dot metadata dot create all. And then inside this, we want to say bind equals engine. All right, and remember in our database.py file, we said we want our SQLAlchemy database URL to just create a SQLite database called todos.db in the location of our to-do app. Now, this will happen automatically when we run the application. So if we open up our terminal and we cd into to-do app, so remember we're in our FastAPI parent, we need to go one directory lower into our to-do app. And now from here, if we say unicorn main app -- reload, we are going to create a new database within our to-do app. So far we can see there's only 4 files, but now if we start up our unicorn, and we run the application, and we hover over to-do app, we can see that it'll automatically refresh, and we now have a new database called todos.db. Now you might be thinking, okay, well, how does this happen? Well, our models.base.metadata.createAll bind equals engine will create everything from our database.py file and our models.py file to be able to create a new database that has a new table of to-dos with all of the columns that we laid out in our models.py file. So this happens all behind scenes on how to create a new database for our FastAPI application using SQLite. All right, so this is awesome stuff on how we're able to dynamically be able to create a database without actually having to write any kind of SQL queries to be able to accomplish this. All right, well, now that our todos.database is now created, we now want to go ahead and install SQLite on our machines so we can now play around with the actual database using query commands. And we want to be able to store information to our to-dos. So let's go ahead and jump into the next video where we dive into SQLite a little bit more so we can start populating our todos.db with some records. Hey everybody, and welcome back to another lecture with Coding with Roby. In this lecture, I'm going to show you how to install SQLite 3 on a Windows operating system so you can manipulate the data of a database, be able to select all from a database, and be able to just completely be able to use a SQLite database from your terminal. To be able to do this, the first thing you need to do is go to Google and type in SQLite 3. From here, you're going to want to go to https://www.sqlite.org. If you want to skip the entire first step, you can just go to this URL, which is sqlite.org/index.html. From the home page, we're going to want to click Download. And when you're in the download page, you're going to want to scroll down until you see the pre-compiled binaries for Windows. And you're going to want to click the very last one, which is the SQLite Tools Win32 x86. You want to click this one because this comes with a lot of stuff. It comes with the entire bundle for command line tools for managing SQLite database files. That's like one of the biggest things you want. So let's download this by clicking on the link. And now once you download it, let's open up our downloads file. And I'm going to extract this. So we're going to need to extract this file that we just downloaded because it came as a zip. And I'm just going to extract it right here in the downloads file. And now the file that we just downloaded should come with 3 files within. We're going to want to copy this or cut it. And we want to hop on over to our PC and then go into our C drive. And within our C drive, let's just paste it in here. We're then going to want to rename this to SQLite 3. And now we have the SQLite 3 file on our C drive. We're just going to want to open this up and grab this path. From here, we're going to want to open up our Systems Environment Properties. You can accomplish this by pressing the Windows button and then typing in ENV for Environmental Properties. From here, let's click the Environment Variables. And inside our system variables, we want to modify path. Inside path, let's say a new environment variable, and let's just paste in our C drive SQLite 3 path. And press OK. And then let's press OK again. And then one more OK. From here, we should be able to open up our command prompt and say SQLite 3. If everything looks correct, you should now get a version of SQLite 3 printed back to you. This wraps up the lecture on how to download and install SQLite 3 on your Windows machine and set up your environment variables. And I will see you in the next video. Hey everybody, and welcome back to another lecture with Coding with Roby. And in this lecture, I'm going to show you how to install SQLite on a Mac OS so we can use the terminal to manipulate the database and tables and columns and all the fun stuff that comes with databases. The first thing we're going to do is install Homebrew. So in my Google search, I'm going to type in Homebrew. And I'm going to go to https://brew.sh. And then from here, I'm going to copy this command. And from here, I'm going to open up my terminal. I'm going to paste in that command and press enter. Here it's going to say you need to type in your password. So I'll type in my password. It'll tell you what scripts are about to be installed. Press the return button to continue. And it's going to download and install Homebrew. Let's now close out of the terminal and let's reopen the terminal. And now you have Homebrew installed on your machine. Now SQLite 3 should come pre-installed on Homebrew. So if we type in brew list, we can see that we now have SQLite. If for some reason SQLite 3 is not installed, we can install SQLite by typing in brew install SQLite. When you press enter, it will install all the dependencies for SQLite. And since I have it installed, let's just use SQLite. We can now run SQLite by typing in SQLite 3. And immediately we can see that we get the version returned to us. We can close SQLite by saying .quit. This wraps up the video on how to install SQLite 3 on a MacBook, and I will see you in the next video. Hey everybody, and welcome to another lecture with Coding with Roby. And in this lecture, we're going to be going over basic SQL queries. Alright, let's start by going over inserting data into a database table. Imagine our to-do database table. A single to-do record within our database looks very similar to this. Our to-do will contain an ID, which is our primary key to identify each record, a title for the title of our to-do, a description that describes the to-do and gives it a little bit more information, priority, which is the ranking of how important it is to accomplish this to-do, and a complete column, which displays if the to-do is complete or not. And eventually we'll be adding a foreign key of owner, which connects this to-do to a specific individual or user. So in SQL terms, how do we add data to a to-do? To start, we need to say which fields of the record we want to add to. we can see the SQL command that says insert into to-dos. So insert into the to-dos table a title, a description, priority, and complete. We can see we are not saying ID, and that's because we want the database to handle this automatically for us and to auto increment so we can't accidentally assign the same primary key to two different to-do records. We then want to type values, which is go to store, to pick up eggs, for as a priority, and false for complete. When we run this, we will be able to see that we are creating a new record in the database. Our title, description, priority, and complete all get updated based on this command, and we now have our database configured to auto-increment the ID on its own. This way we never have to worry about updating the ID ourselves, and we can trust the database to do this for us. Alright, now that we've created one record in our database, let's create another record. We'll be inserting into our to-dos a title, description, priority, and complete. And we'll say the values of these are haircut, need to get length of 1 millimeter, 3 priority, and false for complete. Once we submit this to the database, we can see that we now have two records in our database, one with an ID of 1 and one with an ID of 2. Alright, now that we just went over inserting into our database, let's keep adding to it. Now, I'm just going to pretend we are inserting this data. So let's move on to a new record where we just created a feed the dog as a title. As a description, we are going to be using make sure to use the new food brand with a priority of 5 because we need to feed our dog and not complete. And then let's add another one about watering our plant as a title. Description is inside and outside plants with a priority of 4 and also not complete. Let's add a fifth record of learn something new, learn to program, 5 and also not complete. And lastly, let's pretend we added a sixth record, which the title is shower. And the description is you have not showered in a few days, so it's probably a good idea to take a shower. A priority of 5 because you smell really bad, and complete is false. Alright, well, we now have some data in our database. We now want to be able to withdraw data from our database. So how can we do that? To be able to start, we need to use the select attribute. We can say select asterisk from to-dos. Now in SQL, an asterisk means all columns and rows. So with this example, we are saying select all rows and all columns from our to-dos table, which in reality would just give us everything in that table. So all 6 records we currently have saved in our database will be displayed on the screen. What if we modified our select script just a little bit to only retrieve the titles of our records? We can accomplish this by saying select title from to-dos. By doing this, we are selecting just the title from our to-dos columns. Our response from the database will look very similar to this. We get go to the store, haircut, feed dog, water plant, learn something new, and to shower, with no other information. And that is because we are specifically said we only want the titles from the table to-dos. What if we modified our select script even a little bit more to retrieve the description of all the records? Well, this will be very similar to how we handled the title portion of our select command. We can accomplish this by saying select description from to-dos. By doing this, we are selecting just the description from all the to-do columns. Our response from the database would look very similar to this. We will get to pick up eggs, need to get length 1 millimeter, make sure to use new food brand, inside and outside plants, learn to program, and you have not showered in a few days. Well, being able to get only one column may be great in theory, but in our case, it doesn't actually do much. If we get a title, we want the description as well, and vice versa. Let's go ahead and modify our SQL command a little bit. Now let's type select title, comma, description from to-dos. This will properly select all titles and descriptions from our table, which will give us the titles and descriptions that we are seeking. And there it is, great job. We get the title and description from our to-dos table. Let's keep this going and add another column to our select command. This time we are going to be adding priority along with our title and description. We can accomplish this by saying select title, description, priority from to-dos. This will retrieve all titles, descriptions, and priorities from our columns. And now we will be able to see our titles, descriptions, and how important each task is. Now that we covered the select command from SQL, let's keep this learning up and learn about the where clause. The where clause specifies criteria that a field value must meet for the records that contains the values to be included in the query results. Let's check this out. Okay, remember when we wrote select asterisk from to-dos and we returned all rows and columns from the table to-dos? This time we will be writing the same thing. However, we'll be adding a where clause where the priority of the record must be equal to 5. This means we are selecting all rows and columns where a priority is equal to 5. Therefore, when we run the SQL statement, we will get only 3 of our 6 records returned. This is because only 3 of the records have a priority of 5. But we will be getting all columns of each of these records. Let's try another SQL statement with a where clause. This time, let's write select all from to-dos where title is equal to feed dog. So this means we are saying let's select all rows and columns where title is equal to feed dog. Well, based on our table, we only have one record where title is equal to feed dog. Therefore, if we run this execution, and we will get only one record back, which is feed dog as the title. Okay, now the main use case for using the where clause is when trying to identify a record by ID. We can pretend that our API passed an ID and we want to return that specific ID and record. Well, if we are in the database, we can say select from to-dos where ID is equal to 2. And to put this in plain English, this is saying select all rows and columns where ID is equal to 2. And this time when we run the script, we will get our single to-do record, which has an ID, our primary key, that is equal to 2. Let's now move into the update clause. The update clause is used when we want to update a record in the database. Now to update a record, we will have to use a few different attributes. We will have to say update to-dos set complete equal to true where ID is equal to 5. So in theory, this is saying update all rows and columns to now have complete be equal to true where a record has an ID that is equal to 5. Therefore, the record with the ID of 5 will change the complete column to true. This can be kind of confusing at first, but the more you work with it, the more sense it starts to become. We are saying we are making an update to the to-dos table and then setting a column field to a new value and then just locating the record we want to update to make the update true. Now in the last slide, we used an ID to identify which record to update. This is by far the most practical and best way to update a record, is to always locate the record by the primary key, because the primary key is going to be unique. However, it is possible to push an update when not talking about the ID. For example, we could say update to-dos set complete to equal to true, where title is equal to learn something new. This will essentially update all rows and columns to now have complete equal to true, where title is equal to learn something new. This will work and modify the record where the title is learn something new. However, the issue with this approach is that there could be more than one title that says learn something new, and that means nothing is unique. So if you want to use this approach, always remember that, the title is not a unique name. Therefore, we could be changing multiple records to true. All right, and now for the final clause for this basic SQL intro is the delete clause. This clause is used to delete a record from a database. Again, the best way of deleting a single record is by the primary key, which in this case is the ID. We can say delete from to-dos where ID is equal to 5. This statement says to delete all rows and columns where ID is equal to 5. Therefore, after this statement gets executed, we will be left with a table of 5 records. However, the record with the ID of 5 is completely deleted. Now, in many applications, if you do not want to completely remove a to-do, so a user has a history of to-dos, the application will create a table that holds quote-unquote deleted records. This way, things are not permanently erased, but just removed from the table of the main application, and moved to another table where the table still exists. And as always, you do not have to delete based on ID or a primary key, even though it is significantly more safe. We could write delete from to-dos where complete is equal to 0. This will delete all rows and columns where complete is equal to 0. So if we do not change any of our complete areas to true, we would essentially erase and delete our entire database. This is the risk in using the delete functionality when not using it by a primary key to delete a specific record. Alright, now I know we went over a bunch of SQL commands and the most popular commands when dealing with CRUD operations in case you want to manipulate the data yourself. Luckily for us, SQLAlchemy handles a lot of these commands on the application side, so we don't have to worry about writing the commands ourselves to manipulate the data. Alright, well, cheers friends, and this wraps up this video, and I will see you in the next lecture. Hey everybody, and welcome back to another lecture with Coding with Roby. In this lecture, I'm going to show you how to manipulate our SQLite 3 database using our terminal after successfully installing SQLite 3 onto your machine. So once we're in our project, let's open up our terminal. And the first thing we need to do is cd over into our to-do app. Once you're in your to-do app, let's type in SQLite 3, and then let's type in todos.db. And todos.db is going to be mimicking the database that you created within the folder. So immediately we get our SQLite version, and it's telling us to tap in enter if we want to help. I'm going to scroll our terminal all the way to make it full screen so we can see more. The first thing I'm going to do is type in .schema. This will show you all the tables that are currently within our SQLite 3 database. We can see that we have a table of to-dos that have an ID, a title, a description, a priority, and complete. And then it's telling us our primary key is our ID. So let's insert a record into our to-do table. We can accomplish this by typing in insert into to-dos, and then within parentheses, typing in title, description, priority, and complete. And then making the values go to the store pick up eggs, five and false. And here it's telling me I forgot a semicolon. So you can just type in semicolon if you ever get these dots and arrows. And now let's type in select all from to-dos. However, all is going to be a star, so select star from to-dos. And don't forget that semicolon. Here we can see that we have go to the store, pick up eggs, 5, 0, 0 means false, 1 means true. And then our ID is getting automatically created because we have integer not null. So it's automatically going to increment up so we have a primary key for each element within our table. I'm going to press up on our right arrow pad. And I'm going to press up one more time and then one last time until we get insert into to-dos again. Here I'm going to just modify this list so we can add another to-do to our table. Instead of go to the store, I'm going to say cut the lawn. For the description, I'm going to say grass is getting long. I'm going to make this priority a 3, and then also false. However, I'm going to add a semicolon at the end. Now if we say select all from to-dos, we will get 2 elements returned. We get 2 elements, go to the store, pick up eggs, and we also get cut the lawn, grass is getting long, and the IDs are 1 and 2. I'm going to create one more element. I'm going to say feed the dog. He is getting hungry. I'm going to make this a 5 and also false. And one last time, I'm going to say select all from to-dos, where we now get 3 elements. Now, if you're like me, you don't like the view of how this comes in automatically and by default for SQLite 3. You can change the mode by typing in .mode and then typing in what type of mode you like at the end. A few examples are column. And now if we say select all from to-dos, we're going to get a nice little column list with ID, title, description, priority, and complete. You can do mode markdown. And if we type select all from to-dos, we are now going to get a new list of the same elements. You can do .mode box. Which is going to make it a sealed box as the return. Or you can do my favorite, which is table, which is very similar to the box, but with dashed lines. Now I'm going to create one more element. I'm going to click up until I see our last insert. And here I'm going to type in test element. And I'm going to press enter. If we now say select all from to-dos, we now get a table view of our elements. And now let's say we want to delete test element. We need to say delete an element from this to-dos table where the primary key of ID is equal to 4. And the reason we're using the primary key is because the primary key is the only thing within this entire table that cannot be duplicated. To do this, we can say delete from to-dos where ID is equal to 4. If we now say select all from to-dos, we can see that the element was erased. Now let's go and create one more element. And here I'm going to say a new test element. Now if we say select all from to-dos, we can see that it reused the primary key that we deleted. So as for an example, it doesn't just skip 4 and then go to 5, it reuses some of the elements. And now I'm going to delete this last element. So delete from to-dos where ID is equal to 4. We got my semicolon, and then select all from to-dos. And now we have our starting elements for our new to-dos application. This wraps up SQLite, and I will see you in the next video.